So for factoring these, the first one up here, remember what's the first thing we always look for? Greatest common factor, right? Common factor. Looking at this one, we look at the numbers 35 and 25. Do they have a common factor? Yeah. What's the largest, greatest common factor? 5. Now for the variables, what did we look at in the variables? The largest, or sorry, the smallest power was the greatest factor, right? So we've got x to the 5th and x to the 3rd, so we're going to use x to the 3rd. We've got y squared and y to the 3rd. We're going to use y squared, the smaller of the two. Now to figure out the other factor, we take the original number and we divide it by that greatest common factor that we just found. So we've got 35x to the 5th y squared divided by 5x to the 3rd y squared. So we divide the counts. 35 divided by 5 is 7. X to the 5th divided by x to the 3rd. Subtract the powers. 5 minus 3 is 2, so x squared. Y squared divided by y squared cancels out. Negative 25x to the 3rd y to the 3rd divided by 5x to the 3rd y squared. So negative 25 divided by 5? Negative 5. X to the 3rd divided by x to the 3rd? Cancels out. Y to the 3rd divided by y squared? Just y. 3 minus 2 is 1, so y to the 1 or just y. So we have 5x to the 3rd y squared times the 7x squared minus 5y. Anybody have any questions on that one? Yeah? You lost? Okay. Remember what we did on these, the first thing we did, oops, that's all full, was we had to find the first thing, we had 60, and we wanted to factor that. We'd try to find a factor. We'd pull out a factor, like 10 would come out of 60. Now there are others, there's 10, 15, 5, whatever. But if we found 10, we would divide by 10, what's left over is 6. That's basically what we're doing here, is we're finding a factor to take out. But when we have two numbers like that, let's say we have 24 x to the 5th plus 40 x to the 3rd. When we have an algebraic number like this that's two digits, or two terms, what we're looking for is the largest number that we can take out of each of them. That's called the greatest common factor. And the greatest common factor can be found in a couple of ways. The most methodical way of finding it is to actually factor those numbers. So 24x to the 5th and 40x to the 3rd. If I factor 24, doing this factor tree, and I keep going to break it down, 24 would be 2 times 2 times 2 times 3. X to the 5th, that's 5 x's. 40 is 2 times 2 times 2 times 5 if we factor it out. And x to the 3rd is 3 x's. The greatest common factor is found by finding all of the common factors and then combining them. So they both have a 2 in common. They both have another 2 in common. And another 2 in common. That's it for the numbers. There's an x, another x, and a third x. So if we multiply that all together, 2 times 2 times 2 is 8. X times x times x is x to the 3rd. That is the greatest common factor, or we abbreviate GCF, of those two digits. So that's what we're going to take out of it. Now just like up here when we decided to take out the 10, we did 60 divided by 10 to see what was left over. We're going to do the same thing here. We're going to take this divided by the 8x to the 3rd to see what's left over. So 24x to the 5th divided by x to the 3rd is 3x squared. And 40x to the third divided by 8x squared is just 5. So then what we looked at is we did a few of these and we looked at the pattern. Well, the number here is always just the greatest common factor of the numbers. So if we look at 24 and 40, the largest number that goes into both of them is 8. And then for the variables, it's the smaller of the powers. Oops, come back here. So for x to the fifth and x to the third is the smaller power. So the greatest common factor is 8x to the third. So if we want to do another example, let's have something like 48 x to the fifth y to the seventh plus 60 x to the third y squared z minus 36 x y to the fourth z to the third. So now I've got 3 terms here instead of just 2, but it works the same. I've got 48, 60, and 36. What is the greatest common factor, the largest number that goes into each of those? 8 does not go into 36, though. There's one actually a little bit bigger than 8. 12. Now again, if you're having a hard time finding that, you can always factor them and look for the common factors. For the variables, for x, we got x to the fifth, x to the third, and x. The smallest power is just the x. For y, we've got y to the seventh, y squared, and y to the fourth. Smallest power, bless you, is the y squared. For z, well, z does not appear in this term. So z is not part of the common factor. We use the smallest power, but it has to appear in every term. So here the smallest power is non-existent. So it is not in the common factor. So we figure out what's left over. We're going to come up here and divide this by the 12xy squared. So the 48, x to the fifth, y to the seventh, divided by the 12xy squared. 48 divided by 12 is 4. X to the fifth divided by x. Dividing, you can subtract 5 minus 1 gives you x to the fourth. And y to the seventh divided by y squared is y to the 5. 7 minus 2 is 5. I'm going to erase this because I'm out of room. 60 x to the third y squared z divided by the 12 x y squared. 60 divided by 12 is 5, so positive 5. X to the third divided by x squared. Y squared divided by y squared cancels out. What happens with the z? It just stays there. Then we've got the negative 36x y to the fourth z cubed. Negative 36 divided by 12? Negative 3. X divided by x cancels. Y to the fourth divided by y squared. Y squared. 4 minus 2 is 2. And then the z to the third, there's nothing to change it, so that's just z to the third. So that is the prime factoring there. Now, since this is 3 terms, we should look to see if that can be factored, but it can't. So going back up here, number 2, the first thing we always look for is that greatest common factor. Number 2, since there's no number here, that's really a 1, there is no common factor for the numbers, and there's no x here, so there's no common factor for the variables. So there is no greatest common factor. So the second possibility, if it's 3 digits, like that is, remember was to do that FOIL in reverse, or reverse multiplication. If you're called to do that, we're breaking this down into 2 binomials. So each of these is going to have 2 digits in them, 2 terms. Remember, the F in FOIL stood for first. These 2 have to multiply to make that. So what 2 things multiply to make x? X times x. So that makes the x squared. These 2 have to multiply to make this number. So those two have to multiply to make 20. So that could be 1 times 20, 2 times 10, 4 times 5. We're going to try 4 times 5, or we said 4 and wrote 5, plus 4 plus 5. And we're going to test it. And the way we test it is with this middle digit. So this was the F of the FOIL. This is the L of the FOIL. This middle digit is made from the O and the I, the outside and the inside. So we check the outside. X times 5 would be 5x. We check the inside. 4 times x is 4x. 5x plus 4x is 9x. That is what we want there. So this here is the proper factoring. X plus 4 times x plus 5. So the next one down here combines both of these processes for us. Remember, I said the first thing we got to look for is a greatest common factor. Well, let's look at the numbers. We've got 8, 44, and 48. What is the greatest common factor of those? 4. We can divide by 4. How about for the variables? X. There is an x in every term. And x by itself with no power is the smallest power. So we're going to divide that by the 4x. 8x to the third divided by 4x. Well, 8 divided by 4. 2x to the third divided by x is x squared. Negative 44x squared divided by 4x. Negative 44 divided by 4. Negative 11. X squared divided by x. X. Negative 48x divided by 4x. Negative 48 divided by 4. Negative 12. And x divided by x cancels out. But when I get to this point, now remember when we had the 60, we factored it, we got 10 and 6 or whatever we started out with. The 10 could still be split up into 2 and 5. The 6 could still be split up into 2 and 3. Well, here, the 4x could be split up, but we're not going to bother since that's just a single digit. We usually leave that the same. But this here piece can be split up using that FOIL in reverse. Now, as always, we're going to have 2 digits in each. And those first digits have to multiply to make the 2x squared. So that has to be 2x and times x to make 2x squared. These last 2 digits have to multiply to make negative 12. So it can be a negative 3 and a positive 4, or a 3 and a negative 4, a negative 2 and a positive 6, or a 2 and a negative 6, or even 1 and 12. Negative 1, positive 12, positive 1, negative 12. The only way to know is to pick one and try it and test it, see if it works. So let's pick one of them. Which one do you want to try? What's that? 2 and negative 6. Okay, so we're going to put 2 here, negative 6 there. Let's test it. On the outside, 2x times negative 6 is negative 12x. On the inside, 2 times x is a positive 2x. That adds up to a negative 10x. Not quite what we want. Really close, but not quite. Now, since this is a 2x, the order does matter. So we could switch the order of the 2 and the 6. So it's positive 6 and negative 2. 2x times negative 2 is negative 4x. 6 times x is a positive 6x. Negative 4 plus 6 is a positive 2x. That's not what we want. That's further away than we were. Now, this is one of the reasons that this is a good exercise. The factoring itself really is only applicable in certain engineering applications and electronics applications. But one of the reasons we still do it is there's some great thought processes here. 11 up here is an odd number, correct? 2 and 6 were both even numbers. So when I put those in there, no matter what I was multiplying by, they were going to be even. So there's no way 2 even numbers were going to multiply and then add up to an odd number. So I can't use, the 2 and 6 just aren't going to work no matter what combination I use them in. So I have to either use the 1 and the 12 or the 3 and the 4. So let's look at the 3 and the 4. Let's try positive 4 and negative 3. On the outside here, 2x times negative 3 is negative 6x. 4 times x, positive 4x. That's just negative 2x. That's not what I want. Let's try the 3 and 4. On the outside there, we get 2x times negative 4 is negative 8x. 3 times x is positive 3x, which is a negative 5x. Closer, but not going to do it. Neither one of those came out to be a positive 11. If it came out to be a positive 11, that tells us I just got to switch the positive and negative. 3 and 4 aren't going to cut it. So let's try that 1 and 12. So on the outside here, 2x times negative 1. Negative 2x. On the inside, 12 times x is 12x. That's a positive 10x, not the one we want. But again, we do have to switch the 12 and the 1 and try that. On the outside, we've got 2 times negative 12, negative 24x. 1 times x is a positive 1x. That's a negative 23x. Not it. That's telling us that this wasn't factorable. That is our answer. We're done there. We couldn't split it up anymore. Does that make sense? I know that's kind of mean, but sometimes that's really the only way to tell, is to just pound it out. There are some formulas where you can tell, quadratic formulas and stuff like that, but that's a couple steps above where we're going to go in this class. So let's try another one similar to that. So 8x to the third plus 97x squared plus 12x. Now when I look at that, my first step is always to look for what? Greatest common factor. And there is one here. What is it? I'll give you a hint. It's not with the numbers. It's just the x. 97 is actually not divisible by anything, but we do have an x in every term. So if I divide that by x, 8x to the third divided by x is just 8x squared. 97x squared divided by x is just 97x. 12x divided by x is just 12. But now looking at this, can I split this down any further? Well, we would be looking at, if it does split up, we're going to be looking at the two two-digit numbers there. 8x squared. 4x and 2x maybe? That's a 97 there, right? 4 and 2 are both even. So no matter what I multiply them by, 4 times whatever's here, this is going to be even. This times 2x, that's going to be even. And when I add two even numbers, it's going to be even, right? So with a 4x and a 2x, there's no way I'm going to get an odd result for that middle number. Has to be 1 and 8. Kind of goes against what your mind wants to do, but yeah, it's going to be 8x and 1x or 1x and 8x. Now again, 12 has a lot of combinations. 3 times 4, 2 times 6, 1 times 12. Which one of those can we cross off the list right away? 2 and 6, because we got an odd number there. 2 and 6, there's no way we get an odd number if they're both even. So it's either got to be 3 and 4 or 1 and 12. Which one do you want to try first? Try 1 and 12. Good thought. So put in the 12 and the 1. Bless you. 8x times 1 is 8x. 12 times x is 12x. That adds up to 20x. Not what we want. So do we go to the 3 and 4? What'd you say? Yeah. I was asking if we go to the 3 and 4, but I was doing that mainly to see if you would bite. Switch them. Since these two numbers, since this is an 8x and an x, since they're not the same, switching them will make a difference. 8x times 12 is 96x. 1 times x is 1x. 96x plus 1x is 97x. That is what we wanted. Not so bad? Okay. Where is this a useful thing? Well, we're not going to do it so much in this class, but I do want to show you what the next step would be. This, you can ignore your notes if you want to. You don't need to write this down because it won't be in the homework. But this process of factoring is useful when we have equations that are not linear. They're called quadratic equations. And a quadratic equation has, it's called a degree of 2. In other words, the largest power is 2. So it has an x squared in it. And for example, we might have an equation like x squared plus 11x equals a negative 30. In a quadratic equation, we can't get the x by itself because the x appears twice. There's an x squared and an x. So to solve it, what we do, make it equal to 0. So I have this negative 30 over here. I'm going to add 30 to get rid of that. X squared plus 11x plus 30 is x squared plus 11x plus 30. There's nothing I can combine there. But now over here it equals 0. And now that it equals 0, now I would look at factoring this side here. There are no common factors, but I can do this reverse multiplication. So this is going to, of course, be x and x to make the x squared. 30 could be 1 and 30, 3 and 10, or 5 and 6. Now looking at this, can you see which one it has to be? 5 and 6. Oops. 5 and 6, not 5 and 5. On the outside, I would have x times 6 is 6x. Inside, 5 times x is 5x. 6x plus 5x does make 11x. Now there's a rule in multiplication. 8 times 0 equals 0. That's called the zero product rule. And that's the simple version of it. There's a more powerful version of the zero product rule that says if A times B equals 0, then either A has to equal 0 or B has to equal 0. Or both could possibly equal 0. So looking back over here, multiplying those two equals 0, which means either the x plus 5 has to equal 0, or the x plus 6 has to equal 0. Or it could possibly be both. So solving this one for x, I can subtract 5. X can be negative 5. Or on this one, I could subtract 6. X can be negative 6. And if I went back to this original equation, I could replace x here with either -5 or -6. Both of them would make that original equation true. Well, why is that useful? Well, when we're dealing with gravity and ballistics and stuff like that, it ends up being a quadratic equation like this. Just for fun, William's not here today, so he's going to be our guinea pig. So let's say William's punishment for not being in class today. We're going to launch him out of a cannon. We're going to pretend there's no ethical issues with that. And if we launch him out of a cannon, we're going to launch him up in the air at 80 feet per second. Now in physics, the equation that describes the height of an object that's been launched into the air, the height of that object is equal to the initial velocity times time plus 16 times the time squared. That's not plus, it's minus 16 times the time squared. The 16 is 1/2 the acceleration of gravity. The acceleration of gravity is 32 feet per second. Half of that is -16. So it's part of the formula. It's initial velocity times time minus 1/2 of g times time squared. But anyway, that's the formula. Since we're launching him with a velocity of 80 feet per second, this is 80. We want to know how long does William have to live? Well, when would death occur here? Assuming he safely launches. When he goes up and comes back down and goes splat, right? When he reaches the ground. In other words, at height equals 0. The initial velocity was 80, and we're solving for the time. So this is already equal to 0, so we can factor this other side over here. There is a greatest common factor there. It is 16t. So if I divide this whole thing by 16t, 80 divided by 16 is 5. T divided by t goes away. -16 divided by -16 is -16 divided by 16 is -1. T squared divided by t is t. So that's a -1t or just minus t. So now this can be split up. Either this part equals 0, 16t equals 0. How would I solve that? I'd divide by 16. Well, 0 divided by 16 is 0. T equals 0. That makes sense because when he's launched, that's at time equals 0. He's at the ground. That's not the impact point, right? So 5 minus t equals 0. We subtract 5. Negative t equals -5. Divide by -1. Or just negative. T equals 5. So what that's saying is William has 5 seconds to live. Make sense? So there are applications for this factoring. I'm not going to force you to solve equations like this, but I wanted to put it out there because so many students think, well, why on earth are we doing this? There are applications. You know, ballistics and engineering and stuff, there are a lot of applications. But again, like I explained a little earlier, there's also that combination of thinking of what we did up here with this one, wherever it was. I could eliminate some of the possibilities by knowing it's even or odd. And that the parity, the evenness or oddness of a number is actually a very powerful tool. And starting to, you've seen me do some pretty complex calculations up here in my head. That's because I see some of those patterns. And once you start to see some of those patterns, the rest of math becomes a lot easier. So that's another one of the reasons for doing this. So anyway, there is nothing new today. There's still that quiz from yesterday that is due today at 11:59 p.m. And then there's still that homework that was assigned yesterday that is not due until after break, March 27th. Enjoy your spring break. Have a safe one.